this video, we're going to be talking about how you can use arithmetic sequences to describe a pattern. So as a quick refresher, the arithmetic sequence equation is a sub n equals a sub 1 plus d times n minus 1, where our a sub n is the new term value, our a sub 1 is the first term of the sequence, our d is the common difference to get from term to term to term, and the n is which term you're on, like the 4th term or 10th term or 25th term, something like that. Let's look at an example. So here we have some patterns with some shapes, and we're going to make some tables, and then we're going to describe the pattern from the y values there. So here we have stars. So if we take a look at our first star, first term, there's one star there, which has 5 points, but each point has 2 sides. So here we see that we have a value of, not a value, sorry, but we have 10 side lengths. So when we go to our second term, we see that there are 2 stars, so each one gets 10 sides, giving us 20 sides. When we move to our third term, we can take the 3 stars and times them by 10, giving us 30 sides. And then the fourth term has 4 stars and gives us 40 sides. And our fifth term has 5 stars, which each have 10 sides, giving us 50 sides. So here, we could say that our pattern starts at 10 and then it increases by 10 for each 1 star added, or for each term we're adding 10 more. Let's take a look at our pattern in part B, where we have these circles. So we take a look at our first term where we have the 2 rings. We see that in the first term that there we have 2 circles. If we move to our second term, they've added a ring to the outside. So now we have 3 circles. When we move to our third term, we see again that they've added a ring to the outside, giving us now 4 circles. On our fourth term, they've added another ring to the outside, giving us 5 circles. And when we look at our fifth term, we see that they've added another circle, and now we have 6 circles. So to describe this pattern, we would say that we start at 2, and then increase by 1 circle for each term, or each time. Let's expand a little bit more on this. What does this tell us about these patterns? So we're going to look at it another way. So here, we're going to write the next 3 terms in an arithmetic sequence, and then we're going to graph them and go, gosh, what do we notice? So we first need to find our next 3 terms. So 1, 2, 3. We see that we're increasing by 7. So if we add 7 to 22, that's going to give us a 29. And then if we add 7 to 29, that's going to give us a 36. And if we add 7 to 36, that's going to give us a 42. Now this is our first term, second term, third term, fourth term, fifth term, sixth term, 7th term. So 1, 2, 3, 4, 5, 6, 7. That's our n. Now our a sub n's, those values right there. So 1, 8, 15, 22, 29, 36, and 42. So let's go ahead and let's graph this. I'm going to go ahead and zoom in a little bit to make this a little bit easier to graph. So let's graph these. So let's use this color. We'll use red. So we have 1, 1, and oops, 1, 1. And we see that we don't get very far if we only count by ones. So we might need to count by maybe, if we count by 2. So if we said that that was 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. We want to get all the way, but we're going to get pretty close here. So, and then we'll count by, we just count by ones down here on the bottom because we're only going up to the number 7 anyways. So, all right. So we've got 1, 1. So 1, 1, 2, 8, 3, and 15. And then 4 and 22 is going to be about right there. Kind of hit our max here. But what you should notice is that our graph does something interesting here. Let's take a look at our part B and let's see if we can't find this pattern. and see what we notice that might be interesting. This probably would have been a little bit easier to graph if we hadn't used 4 quadrants and we had only just used just one quadrant. That might have been a little bit easier. So we might do that for this next one. So let's look at letter B. All right, so here we have our terms, right? First term, second term, third term, fourth term. We have to find the next 3 terms. So that'll be 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7. Let's see. Let's put in the ones we know. We know that we've got 20 and 14 and 8 and 2, and it's going down. In fact, it's decreasing by 6 each time. So we're going to take 2 and we're going to subtract 6 from that. And that's going to give us a -4. Then we're going to subtract 6 from that, and that's going to give us a -10. And then we're going to take 6 more away and get -16. So we can now write those values in. So we are in fact going to graph this using just one quadrant. So we're going to kind of ignore that one. And we're going to graph it like this. So let's see here. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4. All right, and then, gosh, we have to go. I guess we are going to need negatives there, aren't we? Because we go to a -16. Okay, we'll make it work. Let's count by 2s again, though, to help make it a little bit easier. So we'll count 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And the negatives as well, and then we'll go 1, 2, 3, 4, 5, 6, 7. Okay, so we have 1, 20, which fits. So 1, 20, and then we have 2, 14, and 3, 8, and 4, 2, and 5, -4, and 6, -10. So 4, 6, 8, 10, and 7 and -16. So that was -10. 12, 14, 16. So now, when you take a look at this line, what do you notice about those dots? What do you notice? What do they kind of form? Does it look like a straight line to you? Yeah, it kind of does. Now, if we just kind of take a quick little look, we see that they all go down 4 over 1. Down 4 over 1. Or not down 4 rather, because we're counting by 2s, aren't we? So we're going to go down 6. So 2, 4, 6. So down 6 over 1. 2, 4, 6 over 1. So here we see that they've got a slope. They all have the same slope. They have a slope of -6. -6 over 1, which is -6. Isn't that interesting? That seems to match our common difference. So here we see that the points lie on the same straight line that has a slope of -6. And if we look at the example above, it's the same type of a thing, except that here our slope, oops, let's try that again. Our slope is the number 7.